Hello everyone, I'm Frank and welcome to Frank Puzzles. This month, I'm trying to upload two videos every day. One that's going to be very easy or easy, and the other one that's of average, hard, or very hard difficulty. Um, and let's just get on to today's puzzle. Today's puzzle is called Toroidal Diagonal Hit Points by Lake. And here are the rules. Normal Sudoku rules apply, which is place the digits 1 through 9 in every row, every column, and every box. Renban. Digits on a purple Renban line form a consecutive set of non-repeating digits. These can be placed in any order. So for example, if this was a 1, there would have to be a 2 and a 3 on this line somewhere. It doesn't have to be in any order, but since they're consecutive and non-repeating, they have to be placed, they have to form that set. Hit points. Clues outside the grid give the sum of all cells that contain a digit equal to the distance of that cell from that clue along the marked diagonal. Okay. Clues outside the grid give the sum of all cells that contain a digit equal to the distance of that cell from that clue along the marked diagonal. Okay, I think I understand. So for example, if a 3 in row 1, column 3, would count towards the 15 clue outside row 4. I see. Okay. So this 3, if it's a 3, would count toward this 15 diagonal. Now, here's the interesting part. In addition, the hit points clues travel around the grid as if it were torus. When a diagonal hits the edge of the grid, it loops around to the other side and continues. For example, the diagonal that starts in row 3, column 1, going upwards would travel to row 1, column 3. So it would travel there, then loop around to row 9, column 4, and finish on row 4, column 9. Oops. Green. So this would be considered one toroid. And this would calculate the hit points possible. Interesting. In this example, a 4 in row 9, column 4 would contribute to the hit point sum. And those are the rules. If you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Interesting. Okay, so maybe it's good to mark the toroid or the hit points values. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I guess we'll do that then. So these are the colors. And then this would go over here. Then you have this one, which would go over to here. You have this one, which continues on here. You have this one, which would continue on here. You have this one, which continues on here. You have this, the positive diagonal. I can't. And then you have the yellow. which goes to here, up to here. Oh, this is confusing. Huh. Oh, and I forgot this one. So this is blue, then it goes down to here. So perhaps the most interesting is the 0. That gives us a decent amount of information. 15, the problem with 15 is it could be up to 5, or it could be down to 2. It can never be 1, right? Because each one would have to match contribute its value. So it could be 2, 3, 4, 5, 2, 3, 4, or 5, right? So for this one specifically, we know that it cannot be 1, 2, 3, 4, 5, right? Because if this is 1, this has to have 2 and 3 along it. So this cannot be 1, 2, 3, 4, 5. So it cannot be 5. It could be 2. It could be 4. It could be 4. It could be 3. So it could be 2, 3, 4, 6. Huh. This is 0. So this cannot be 1. This cannot be 2. This cannot be 3. This cannot be 4, 5, 6. I don't know if that helps very much, right? Um, it does limit things, but not by very much. So that's not that helpful there specifically. Huh. Yeah, maybe I just have to look at one of the 15s and attack it, right? There are 8 of them. There are 8 of them. Are they ever the same? I don't think so, right? So say when this crosses the purple, right? This would have to be 2 to count for this diagonal, but it would have to be 5 to count for this diagonal. Similarly, this would have to be 2 to count for the purple diagonal, but 5 to count for the black diagonal, right? Same for this. This would have to be 3 for the yellow diagonal. This for the black diagonal would have to be 7. So I don't think it can ever be the same for ones where they cross paths. Except for this one, right? This one's 5, and this one would be 5 too. That's the only one? Maybe? Anything gray starting here. So this would be 2 and 5. This would be 4 and 6. This would be 5 and 8. Yeah. This would be 7 and 9. Yeah, so I don't think any of those match. So for the only one that does is potentially this one, right? This would be 4 and 6. Oh, wait, no, this is 2 and 2. This could be 2 also. So this could be 2. The yellow's different. That would be 1 or 9. So this one could be 2. This one could be 5. I think those are the only ones, right? So this one, it has to start with that, right? But the purple one and the gray never match. These never cross. These never cross. This could be red. There's no other one that matches really along those. Yellow, there's nothing that fits that. Blue doesn't go across that too. Nothing match, yeah. So this one or this one. Okay. This is interesting. So how to approach this then? So this could be 4 and 5. That actually works fine. If this is 4 and 5, though, neither of these can be work. So none of those could work. So it would have to be 15 without a 4 or 5. It could be 6 and 9. So everything could be 6 and 9, 7 or 8. And then there's all the 3 possibilities for 1. Maybe I try 1 through 5 and see if any of those work, right? That way, that allows us to eliminate potential ones, right? So this obviously can't be 1 through 5, because if that's 1, this would have to be 2 and 3 here, and the 2 and 3 does not work. So 5 does not work for this one. We're just going to mark that as an X. 5 does not work as this one. This one actually could be 1 through 5, right? 1, 2, 3, 4, 5. That seems feasible. Okay, nothing out there outlandish. 1, 2, 3, 4, 5. That one's possible too. This is 1, 2, 3, 4, 5. That seems possible. 1, 2, 3, 4. This would have to be 5, but that's 5. So that's possible. 1, 2, 3, 4. This would be 2, or this would have to be 2 then. That's 5. So that's possible. 1, 2, 3. This would have to be 4. This would be 4 and 5. That's possible. 1, 2. Okay, so that wasn't very useful. So the only one we eliminated was the top left hit point diagonal. Okay. Huh. Hmm. If this is 1, 2, 3, 4, 5. So let's say this is okay. We have 1, 2, 3, 4, and 5. This cannot, this has to be 6, 7, 8, 9. This would have to be 2. This is 6, 7, 8, 9. I don't think that works. This would have to be 1 or 3, right? And since that's 1 or 3, this would have to be 2 or 4, but the 2 and 4 are both accounted for. So this cannot be 1, 2, 3, 4, 5. Okay, so we've got another one that's eliminated from 1, 2, 3, 4, 5. But all the other ones are fine. If this is 5... So only the diagonals are cannot be 1 through 5. We can remember that. Okay. So this has to, okay, if one of these is 5, we know it's 1, 2, 3, 4, or 6, 7, 8, 9. Or it could just be a 5 in there, right? It would have to be, yeah, so if it's not, if 5 is not on the Ren band, it's 1, 2, 3, 4, 6, 7, 8, 9. Um. Oh, that's interesting. Can there be multiple 1 through 5s? Maybe. So if this is 1, 2, 3, what this does is it eliminates the possibility for the purple to be 1 through 5. Oh. No, wait, hold on. It eliminates the possibility for any of these to be 1 through 5. Right? So if any of the, like, say the yellow, or not the yellow, the light white, the white, the green, the purple, or the red have any of their digits correct, if they have any of their digits correct, that eliminates the possibilities of every other one to be correct. Wait, how does that work then? Right? Because this one. Wait. So say this was 6 and 9. Red can no longer have a 6 or a 9 there. Neither can white. Neither can purple. And they never, the only ones where they interact are red and white and yellow and white. Or not yellow and white, green and white. But they can't add up then. That can't be the case. Wait. I think it's the case though. The only ones that possible for this to be 1 through 9, it eliminates every other one that starts there, right? So the purple also has the same ones from 1 through 9. So does the green, and so does the white, but the white can share. Oh, it shares with the green, and it shares with the red, and it shares with the purple. Ah. So then this has to be 2, 5. Oops, I can't type. 2, 5, and 8. That has to be the case. Yeah. So that has to be. So then this is 7 or 9. It cannot be 9 because this is 15 already. So this is 7. We know that's 7. So either the purple or the red or the green is 9. Okay, so then, yeah. So then this cannot be 1. This has to be 7. This is 5, so this forces this to be 1, 2, 3, 4, or 6, 7, 8, 9. Okay, yeah, that's pretty clever. I like that. So then this is forced to be, yeah. So this has to be the 15 that has to match everything else because every other one is eliminated, but every other one that starts in the same column is eliminated for the other uses, right? So it's kind of like a magic square in that if you use one, you can't. It's a distinct set. It's a unique set where basically all the ones that add up to 15 here in the green one cannot match the purple one, cannot match the red one. So then that's 15 plus 15 plus 15, which is 45, and it forms a distinct set. So this is 2. So this cannot be 1 here. This forms a 2. So it cannot have a 1 or a 3. So both of these are invalid. So this cannot be. Okay, so we know none of these can be. And then obviously this one's already not. Maybe. Uh, I'm going to basically try to figure out the colorings. And I think yeah, the diagonals shouldn't be so bad since I can figure it out. Oops. So the greens are basically counted. The reds are not counted. Though it could be counted for some and not for others. Right? Hmm. This cannot be 1 and 3 because it has 2 already, right? So it yeah, and 2, 3, 9 is adds up to 14. Oh wait, no, it could be one. No, it has to be 3. It has to be 3 digits. Because we know that. I guess it doesn't have to be. It could be 4 digits. It could be 4 digits, right? Huh. It could be 4 digits. Didn't think about that, but yeah. It could be 4 digits and then it could be another, like, so this could be 7 and 8. Oh, this can't be 7. Okay, so this one's already out for this diagonal, right? So this is already out because that has to be 7. It cannot be 9. So the 9 does not work. This is not 7. So then it has to be at least 6. 1 and 6, 2 and 5. It could be 1, 2, 4, possibly. So it could be 1. Okay, it can't be 2. So then it cannot be 4 for this diagonal. So so this cannot be. This can't be 2. This can't be 5. So it's either 3, 4, or it's 1, 6. Interesting. So that's 3, 4, or 1, 6. This one cannot be for this diagonal. I guess I could do lines, right? Uh, I don't know. And then yeah, maybe this is easier. This is probably easier to see too. What's going on? Yellow, let's do that one. And then gray. And then we have. Wait. Oh. That. I'm not sure I like that, but okay. Uh, huh. I don't think I like that. It just clutters things up. You just have to remember. Okay, so this can't be 2. So this is 2, 5, 8. This would be 1, 2, 3, 4, 5, 6. Okay, so this can't be. And this can't be 4, 5, 6, 7, 8, 9, right? Okay, so the 8 cannot be with 9. This can't be 7 anymore, so it has to be, it cannot be 2 or 5. So that forces either 1, 6, 8 or 3, 4, 8. We don't know which. So this is either 1 and 6, or this is 3 and 4. For this diagonal, either the 9 is with the 5 or the 9 is with the 2. Right? Okay, so what are the possibilities? This can't be 1, obviously. So this, okay, so the 1s could be here, here, or here. The 3s could be here. It cannot be, it could be here or here. The 4s would have to be those. The 6s are those. The 7s specifically have to be here or here. It cannot be this one. And the 9s are here and here. Okay. So one of these two is 9. One of these two is 7. One of these 3 is 6. So if this is 4 and 3, this would have to be 5 or 3, which is neither of which is possible. So this cannot be 4 and 3. So we know then this is 1 and this is 6. So those are both good. And therefore this can't be 1. This can't be 6. Do we need to color these in? I don't know. Okay, so, whoops. This is 7. Okay. So 7 is one of these two. 4 is one of these two. Okay, so, it has to be 3 and 7 and 4 and 9. Right? It cannot be 4, 5, and 7. It can't be 4, 5, and 9. This is at most 3. This has to be 3 and 7. So this is 3. This is 7. Therefore, on the diagonal, that can't be 4. This can't be 3. So this is 4, and this is 9. Right? So the diagonal works. So this is 2 plus 4 plus 9. This is 1 plus 6 plus 8. This is 3 plus 5 plus 7. This is 2 plus 5 plus 8. Right? So one of these is 1, 2, 3, 4. The other one's 6, 7, 8, 9. Okay, so this cannot be 4. Okay, so that solves all the ones that start from column 1. Now these. Okay, so this one cannot be 2. Okay, so this is similar. Everything that starts with row 1 cannot be the same. So we know for this diagonal, 2 does not work, 5 does not work. Oops. Red. And 8 does not work. So the 8 would be here. Okay, so then we know that, okay, so possibilities for 1 is here. Possibilities for 3 are here. Then you could have 4. 4. It cannot be 5. It could be 6. 6. It could be 7. Oh. Okay. Well, that shows that. And then it could be 9 and 9. So this can never be 7. It can't be 4. This is 2. So this is 2, 3. So this has to be the 7. 9 and 9, 6 and 6. Okay, so the 9 can no longer be here, so this is 9. It could be 6 and 9. That's still valid. So this cannot be 1, 2, 3, or 4, right? It cannot be 1, 2, cannot be 2, 3, cannot be 2, 3, 4. Can't be 4, 5. So this is 6. This is 6, 7, 8, and 9. So this can't be 6 or 7. This can't be 9. So this could be 9 and 8, 8 and 7. And those are the only possibilities. So therefore, this is 1 through 4. Because of red band, 1 through 4, 1 through 4. This is 6, 7, 8, 9. This is 6, 7, 8, 9. So we know that the 6 is here and here. So this cannot be 6. So this is 7, 8, 9, 7, 8, 9. This has to be 6. That doesn't work. Why is... Did I mess up? Oh. This has to be 6. So again, this can't be 6, this can't be 6. I don't know why I screwed that up, but that's a 6. And so this has to be 5. So we have 6. So this is 7, 8, 9. This is 7, 8, this is 7, 8, 7, 8. So this has to be 9. So this is 9. This is 5 or 6. This is 6. So again, one of these two is 6. This is 7. We know that's 9. It cannot be 1, 2, 3. So it's 1 and 6 or it's 3 and 4. This is... No, that's not right. It's 1 and... Wait. It has to be 6 and 9. Right? What else? It cannot be 1, 3, 9. It can't be 1, 4, 9. It can't be 1, 6. It has to be 6 and 9 there. It can't be 3, 4, 9. Yeah, so this has to be the 6. So this is 6. Which means this can't be 6. Also, none of the other ones can be 3 or 1. So this has to be 1. This is 3. This is 3. No 3, no 3, no 3. So this is 1, 2, 4. This is 7, 8. Okay, so we have the row 1 diagonals and the column 1 diagonals all set. Right? This is 9 and 6. And this is 1, 3, the 4 also. 1, 3, 4, and 7. So this can't be 4. Okay, so now we have this diagonal. So 2 does not work. This could be 4, so that could work. This cannot be 1, 2, 4. That doesn't work for that. So this would have to be 1 or 2. 1, 2, 3, 4, 5, 6. Cannot be 7, so that's out. This could be 8. This could be 8, and can this be 9? If this is 9, this is 8 and 7. So one of either 8 or 9 has to be valid, right? So none of these are valid for this 15. It has to be 2, 4, or 9, right? 3's out. 5, 6, and 7 are out. And the only one that forms correctly is 4, 2, and 9. And that's solved for that diagonal. So we have all the diagonals solved now. It's 2, 4. Okay, well, yeah. We need to make sure that the other ones. So then this is the only green one possible. This is green, and this is green. Because of this, we know this is 7 and 8 in these two spots. So that's 7 and 8. Let's remove the reds. Everything else cannot be on the diagonal there. So this cannot be 1. This can't be 1. This can't be 1. This can't be 1, right? Okay, so this is, we know this is 0. Okay. So let's just, okay, 3, 5, and 7. So this is 3 and 5. This is 3 and 5. Okay, so that has to be 5. This is 5. This is 3. This is 1, 4, 6. This has to be 2, 6, and 2, 8, and 9. This is 2, 8, and 9. This is 2, 8, and 9. Okay. We have 7 and 8 here, and 7 and 8 here. Okay, this has to be 7. This is 8. This is 7. This is 8. So this can't be 8, therefore this is 8. Ones, we don't have very many. Twos, one of these is 2. So this could be 2, no 3, 4, 5, 6, 8. 2, 4, 5, 6, 8. 2, 4, 5, 6, 8. No 2, 4, no 2, 8. No 5, 6, no 4, 6. Okay, so this is not 1. Yeah, okay, so for all the column 1s and all the row 1s, they should all be fine because they are in a distinct set and they've already been eliminated. Now for this 15 and this 15, we don't have those. So let's color these. Wait, no, we do. Well, no, we still don't have those really. Okay, so let's do lines. That's easier. 6, 7, 8, and then this is 9, so that's fine. Let's do the blue. 1, 2, 3, 4, 5, 6, 7, 8. Or that'd be 9. And then we have, let's make it orange. Oops. Orange. 1, 2, starts from here. 3, 4, 5, 6, 7, 8, 9. Okay. So, oh, this is 15 also. Interesting. Okay, so I have to do that then too. So this one doesn't work. This is working. That's a 6. This doesn't work because it's not 5. So it cannot be 6 and 9. It can't be 6 and 8. That doesn't work. It can't be 6 and 7. That doesn't work. Okay. So it has to be 6, 4, 3, 2, right? It has to be 6, 4, 3, 2. That's the only way that it works with that set. 2 plus 3 plus 4 is 9. Yes. So then this has to be 4, 3, and this is 2. And this cannot be 1. So these are green also. This is green. And everything else cannot be. Okay, so this was taken, yeah. So specifically this one, that cannot be. So we just know that can't be 1. This can't be 1. Okay, so let's go through the possibilities. 1 could be any of these. This can't be 1, 2, 3, 4, 5, 6, 7. Oh, this can't be 2. So this is 9. This is 2. This is 1. This is 2. So the 1 has to be one of those. The 1 is one of those. Okay, so this can't be 2. Since that can't be 2, this is the only possibility for 2. Where are the 1s? This can't be 1. Any of these could be 1. Okay, 2s. 2 has to be either here or here. And it cannot be here or here or here or here. So this is 2. So we got 2 and 2. So those should be all the 2s. 3s. 3 could be here or here. Both of those seem fine. 3 or 3. What other ones? We have one of those is a 3. This can't be 3. This can't be 3. So one of these 3 is a 3. This can't be 3. Oh, okay. Well, there you go. So that can't be 3. That can't be 3. Therefore, this is 3. So this can't be 3. This can't be 3. This must be 3. 3 is one of those 2. 3 is one of those 2. And those are both not. This one's 8, if it would have to be. But that doesn't matter. This is 5 and this is 7 and 9. So that's 7. This is 9. This is 4. We have 1. Okay, so this cannot be 1. So we have 1, 5, and 6, and this can't be 1. It could. Could be 5 or 6. Okay, so we have all. Do we have? We don't have the 4s. So this has to be 4. What other 4s are there? One of these 3 is 4. One of these 3 is 4. And one of these 2 is 4. So we got 4s. 3's one of those. 5's. One of those 3's 5. This can't be 5. This can't be 5. Aha. So we have a 3-5 pair here. So this can't be 5. This can't be 5. One of these is 5. One of these is 5. Ah, so this is a 1-5 pair. Okay. 1, 2, 3, 4. This is 6 or 8. Okay, so that's 6. This is 6. This is 8. This can't be 6. So one of these 2 is 5. One of these 2 is 5. There's a lot of 5 possibles other than the other ones. 6s. One of these is 6. One of these is 6. One of these 2 is 6. That can't be 6. That can't be 6. So we have 6 or 6. That can't be 6. One of these 3 is 6. 7s. This can't be 7. This can't be 7. So now we know this is 7 specifically. This can't be 7. This can't be 7. One of these is 7. Ah, so we have a 3-7 pair now, too. 8s. So this is 4, 8, and 9. So this has to be 9. So this is 9. This is 4 and 8. So we have 4 and 8. Okay, so that can't be 4. So this is 8. This is 4. This is 6. This is 5. This is 8. This is 1, 4. This is 7. So we have 7, 8, 3, 7, 5, 3. This is 1. This is 5. So this can't be 1. This can't be 1. This is 1. We already have the 1, 4, 6. I think it has to be 9. So this can't be 9. So then we know this is 6. This is 1, 4, 1, 9. So this is 1, 4. So this cannot be 4. This is 1. This has to be 5. So this is 1, 6, 1, 6. So this is 9, 4, 1, 4. This is 1, 6. This is 1 or 6. So this cannot be 1 or 6. So that forces this to be 8. This is 9. We have 1, 6, 1, 6. This is 1, 6. So this is 5. So now we have 5, 6. This can't be 6. So this is 6, 1, 5, 1, 6. And that's the 1. And that's the solution. Interesting. I like the break-in. The break-in was very interesting about like how you had to figure that out, that each of these distinct set hit points, quote unquote, had to form a distinct set if they started on the same column or the same row. Except when they crossed over. So that was very interesting. I hope you enjoyed it, and I'll see you next time. Take care.